Good afternoon, sir. My name is M. Tirmalesh from CSC G section. Topic: Extrinsic Semiconductors, P-type and N-type. Subject name: Engineering Physics. Subject code: 23PHY01. Roll number: 244Z1A05DK. Branch: CSC G section. Extrinsic Semiconductors, P-type and N-type. Introduction to extrinsic semiconductors. Extrinsic semiconductors are the materials whose electrical properties are modified by the addition of impurities. The process of adding these impurities is known as doping. Extrinsic semiconductors are classified into two main types, p-type and n-type. This is the diagram of extrinsic semiconductors. Basics of semiconductors. Semiconductors have electrical conductivity between that of conductors and insulators. Pure semiconductors like silicon do not conduct electricity well without doping. The conductivity of semiconductors can be enhanced significantly through the introduction of impurities. This is the diagram of basics of semiconductors. Doping process. Doping involves introducing specific atoms into the semiconductor lattice. The choice of dopant determines whether the semiconductors become p-type or n-type. Doping concentrations can be controlled to tailor the electrical properties of the material. N-type semiconductors. N-type semiconductors are created by doping a pure semiconductor with donor atoms. Donor atoms such as phosphorus have more valence electrons than the semiconductor materials. The excess electrons from donor atoms increases the conductivity of semiconductors. Energy band diagram of extrinsic semiconductors. First one is the n-type semiconductors energy band gap and second one is the p-type semiconductors extrinsic band gap. Characteristics of n-type semiconductors. N-type semiconductors have a higher concentration of negative charge carriers or electrons. The majority carriers in n-type materials are electrons, while holes are minority carriers. N-type semiconductors displays increases conductivity with rising temperature due to enhanced electron mobility. Diagram for semiconduction as shown in the figure. P-type semiconductors. P-type semiconductors are formed by doping with acceptors, atoms that have fewer valency electrons. Common dopants for P-type semiconductors include boron and gallium. This results in creating of holes or positive charge carriers which facilitate conductivity. This is the diagram of p-type semiconductors. Characteristics of p-type semiconductors. In p-type semiconductors, holes serve as the primary charge carriers, which electrons are the minority carriers. The presence of holes allows for electrical conduction as they can move through the lattice. P-type materials exhibits conductivity that increases with temperature, similarly to n-type semiconductors. Comparison of p-type and n-type. N-type semiconductors have excess electrons as charge carriers, while p-type has excess holes. The electrical conductivity mechanism in both types differs due to their charge carrier dynamics. Understanding the difference is crucial for designing electronic devices such as diodes and transistors. Applications of extrinsic semiconductors. Extrinsic semiconductors are fundamental in the manufacture of various electronic components. They are widely used in devices like diodes, transistors, and integrated circuits. The ability to tailor the electrical properties through doping has revolutionized the electronic industry. Conclusion. Extrinsic semiconductors play a vital role in modern electronics through their enhanced conductivity. This distinction between p-type and n-type materials is essential for completion in semiconductor technology. Understanding these concepts provide a foundation for advanced in electronic devices and systems. Thank you.